So basically the first thing we're going to do is we have to convert the architectural plan to a structural plan. And how do you do that? You remove all the architectural fixtures except the walls. So we basically will start by removing all the fixtures except the walls. So I click on the room and right click to select similar, delete, right click. So basically what I'll be doing is just to remove the architectural fixtures, So we are done converting from architectural to a structural plan. So we removed all fixtures except the walls. So control. Next now is we close all openings. We close all openings so that we're able to form a closed loop. All these openings we close that. Now how do I do that? We use the command to the extend command. That is, I click on extend. Click on extend. Enter. Then I'll begin to close all the openings. 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 Begin to close all of that. We are done closing all stuff. We are done closing that. We are done closing all the openings. So now for us to remove the unnecessary lines, that is the lines that are not needed. These lines here, make sure we remove them. They are not needed. They are not needed. We are done removing the unwanted lines. Next now is for you to form your architectural your structural grid line. The structural grid line, that is the lines that will pass through the center of the walls. The lines that pass through the center of the walls. So I'm actually using a wall of 225. So 225 divided by 2 give me 112.5. So I'm going to make an offset of 112.5. 112.5. Enter. So I'll start offsetting these walls. Start offsetting to the center. So we offset all. Then I'll bring out a triangle. A rectangle. Click here. Then make a copy of it. Let me click this as my reference point. Select here. Then copy to this same page. Then click on my extend tool. Select this as my boundary. Enter. Then start extending those ones I have set at the middle of the wall, that is at the center of the wall, start offsetting them to touch those, to touch the triangle, the rectangle that will form as our boundary. So we check for the ones we not actually, if there's anyone we do not actually extend. So I think we extend all. Then I can now delete this and now delete this. Yeah, then I will change the color of this, or this one extended far beyond this. Wrong. Let's just dive back to this place. Okay. Okay, we change the color. Can make that magenta, which is alright. Then center lines have a particular way of representing them. So I will select on this, I'll select on the grid lines, come to line type, select center, and if you observe, it's not showing well, so we have to increase the line scale, the line type scale. Let's make use of 80, enter. I think it's visible now. This should be okay, so we're making use of this one, making use of this, or let's reduce it. I don't like the way it looks. Let's see if we can reduce it to 40 and see what we have. Let's reduce it to 40, enter. Okay, I think this should be okay. Yeah, I think I like this one now. I like this. Then if you look at these two grid lines, they are very close to each other. So let's actually see the dimension of these two grid lines. Let's see that the dimension of these two grid lines. Wow, the dimension is too small. Let's edit it that by using the dim style to edit the dimension. Let me use this one, modify. Let's set the primary unit. You can set it to 00 so that there won't be any decimal. Let's increase this to, let's make it 100. Let's see. Okay, set current, close. Then from here to here, what do we have? It's bigger, so let's see if we can, let's reduce that to 80. Let's reduce that, so let's use 60. Let's see how it is. Let's make it of 60, enter. Okay, set current, close, click it, dimension line, click on this and click on this. Okay, I think we'll leave it this way. This is actually 88, so which is very small. Let's look at the architectural plan and see if what we can do to actually see if we can make them have the same grid line. And these are the two walls that are actually giving us that close grid line. So we have a toilet here. We have, wow, okay, I think it didn't, there's a mistake, it didn't indicate what is there. So but let's see the size of this toilet and see if we can actually reduce the size of the toilet. Dimension, okay, from here to the center of this. let's delete this. They have the dimension. So roughly you can see that this toilet is about 1613. So I think we can actually reduce this wall of this toilet to have the same grid line as this one here. Then we'll come back to this. Before you make any adjustment like this, please make sure you inform the architect of what you are about to do. Make sure you inform them of what you are about to do before any adjustment. Okay, click on move. Select this because I want it to be on the same level as this. I come to this place, wait for some time, then move this back to actually trace the same line. Okay, so I can now delete this, okay, and delete this one too, delete this. So see, and I made them have the same grid line. The same thing here too, same thing here. Then move them. Okay, wait for some time, trace it back. Okay, click. Okay, wow, okay, let's do that again. Then move. Let's on this one, come to this place, wait for some, then move this back here, click. Then I can now delete this one. I can now move this, stretch it down to this place. Okay, close it. And now stretch this. Wrong. Okay, can now stretch this. I can now reduce this one too down to this. And these two, reduce this one, reduce this. So we see that now made them. This isn't been. So next now is to start placing the column. So the ground floor plan is what is used to generate the first floor general arrangement, while the first floor plan is used to generate the third floor or the second floor general arrangement, while the second floor plan is used to generate the third floor general arrangement, and it continues in that trend. So we are dealing with a one-story building. Then the ground floor plan we used to generate the first floor general arrangement, while the first floor plan we used to generate the roof general arrangement. So, and also the size of your column, the minimum in Nigeria to be approved is a 225 by 225. Then you have 225 by 230, 225 by 300, 225 by 500, and depending on the load the load that is coming to the structure. So because it's a one-story building, we're using a minimum of 225 by 225. So I'll pick my rectangle, enter the sizes, 225 at the first point, 225 by 225, enter. Okay, let's measure. I'll see what we have. That is 225, 225. So we got that. I want to move it to closer to the. I want to move it to closer to the plants. So we'll now hash inside the rectangle. So I want to use a solid pattern with a red color. Can now hash. Then we make a copy of it. We start placing at this intersection. Start placing it at these intersections. Start placing the columns at these intersections. Start placing. Okay, we'll come back for this one. Let's continue. Start placing at those intersection point. Okay, so this one you are seeing here is an aesthetic column. So this is an aesthetic column. They have their own sizes, so that's why we're going to hash it separate. So we're going to hash the aesthetic column separate. Hide that separate. We come to this. Okay, escape. So we're done placing. The next now is to make some editing to this column. Now, when it comes to designing, you have given to different engineers to make sure to design this. They will have a different pattern entirely, because you as an engineer, you have to be creative in your own way. So let's check the dimension of this from the center to the center of this. You have 2.5. Okay, so let's check the center from here to this place. You have 4025 actually, 4025, and dimension from this to this you have 1525. So this from here to this is still okay to make it one panel. If you can decide to remove this entire line together with the column, you can decide to remove all of that. It is your choice, the designer. Well, I want to make that a secondary beam by removing this column. So if I remove the column, this now becomes a secondary beam. What is a secondary beam? A secondary beam is a beam that is being carried by another beam. So these two beams are actually carrying this beam. So this is a secondary beam. So the same thing with this one. I can actually remove this column and make this one serve as a secondary beam. Okay, the same thing can happen to this one too. You start removing this column, making it as a secondary beam. The same thing to this, same thing to this, same thing to this. Delete. Okay, delete this one, delete this one. So I think this is okay now. Then I'll copy the columns here and superimpose and see those ones that actually started from the ground level to the first floor, or to the roof level actually. So let's similar, make a copy, and click on this, comes to this place, and yeah, Okay, this is nice. You can see that the columns are just actually started from the ground floor up to the roof level. So and that makes us have less work to do. Not all your columns that will start from the ground level will reach the roof level. Some actually will stop at the first floor level. So we are done placing the columns now. Then we start placing the slab. We start placing the slab now. The slab, let's dimension this from column to column, because that will actually help us to determine the type of slab we have. So I will dimension from column to column. So I think this is okay now for us to determine the type of slab we have. Okay, so when you take a look at this picture, let me try to zoom in. So when you take a look at this picture, this is a section of a slab. From this place now, look at the pointer. From this place down to this place is the thickness of the slab. From here to here, that is from the top to the center of the reinforcement, is known as effective depth. So for you to get the thickness of the slab, you have to be the effective depth plus the bar diameter over 2 plus the concrete cover. Your bar diameter in Nigeria, the minimum bar diameter you can use is Y12. What does Y12 means? Y means it symbolizes a high yield steel, while the 12 is the diameter of the reinforcement, so it is called Y12. So it's going to be, and that's what we're going to use, Y12. So it will be 12 divided by 2, which will give you 6 here. The concrete cover, the minimum concrete cover for slab is 20 millimeter. So we're going to use that because the exposure of the slab is found within the building, and the exposure is not a severe exposure or a harmful environment. So we're going to take a minimum concrete cover of 20 mm. Then for you to get the effective depth, the effective depth is given as Lx over modification factor multiplied by span to depth ratio. The modification factor we're going to make an assumption of 1.5 since we are dealing with a duplex. Then your Lx is the shortest part or the shorter part of your slab. Then the span to depth ratio, it has a value assigned to it. If you go to BS 8110, you have these values here. Now for a simply supported slab, you have 20. Continuous slab, you have 26, and the cantilever you have 7. Sorry, you have 7. Okay, so and for us to check these ones, for us to actually know the type of slab we have, let's use this as an example. We have 3895 and we have 4763. So the shorter one is the Lx, which this one is shorter one is Ls, so is the Lx. Then the longer one is 4763, is known as your Ly. So to know if it's a one-way slab or a two-way slab, a one-way slab is a slab that only bends in one direction. It's a slab that bends only in one direction, while a two-way slab is a slab that bends in two directions, that is in the Lx and Ly direction. A one-way slab bends only in the Lx direction. So when your Ly over Lx is equals to 2 and greater than 2, it is called a one-way slab. When your Ly over Lx is equal or greater than 2, it is a one-way slab. But when your Ly over Lx is less than 2, it is a two-way slab. So if you do 4763 divided by 3895. You have 1.22. so you see that is not up to 2. So this is a one-way slab. Then if you decide to try for other ones, you will see that you have all of them to be a two-way slab. Actually, that is 1.22. I take that back. 1.22 is a two-way slab because it's not up to 2. Then if you try to carry out the same test for all the panels we have here, you see that they are all two-way slabs. So but let's check for this. We have 219. We have 2195 divided by 110. I think yes, yeah. You have 1.995. So because you have 1.9995, so you can actually make an approximation of 2 at that point. So this is equals to 2. So this one now is a one-way slab. So this only becomes the one-way slab. So this is your one-way slab. Okay, so all of that ones are two-way slab. Then it's only this that now becomes a one-way slab. So what is the nomenclature to represent a one-way slab and a two-way slab? So that is what we're going to do next. We're going to show you how to represent a one-way and a two-way slab. So I'll make my line. Okay. Then click this now at a particular angle. Delete, escape, sorry, and then make a copy of this. Tag it here, down, yeah. Then make a copy too. Make a copy. Okay, have it here. Then we now rotate this one. Make a rotation. Rotate it to about 180 degree. Okay, about 190 degree, yeah, not 180. Then I'm still gonna make a copy of this, an extra one. Click there. I can probably keep this. Then paste it here. Escape. Delete. So remember I said a two-way slab is a slab that bends in y direction and in x direction. So this is actually shows bending. This actually shows the direction of bending. So it's bending in the x and y direction. This is a way of representing a two-way slab. Wherever you see that, you should know that this is a two-way slab. Then this one is for one-way slab, which shows that there's the bending is only occurring at one particular direction, which is the LX, the shorter part. That's where the bending will occur. So that is the reason I actually made it horizontal, because this is the shorter part of this one, so it's going to bend along the shorter part. Okay, this ones, as you can see, this is a closed loop. This closed loop, closed loop, closed loop. These are called panels. For a slab, these are called panels. These closed loops, they are all slabs, so they are called panels. So we're going to bring a text to write the panels you have. We're going to bring a text to write the panels you have. We'll just drop this there. Okay, I'm going to bring a text. Okay, let's wait for it to be. Okay, we have, can write as P1. Write P1 for now. Okay, highlight, come to text height. We can make this to be 250. Enter. Okay, how that comes up. Okay, so next is now to show the thickness of the slab. Show the thickness of slope. We're going to be using the worst case method. That is, we take the highest parts to design all the other parts. So if you look, this is the largest of them all. This is the largest of them all. So I'm going to use this to design for all other panels. Look at what we have. So I have to get my D then before that, plus add all this together to get the thickness of the slab. So if you look at this now, you see that this is a continuous slab. This is a continuous slab. This is a continuous slab. This is continuous. This is a continuous slab. So we're going to be making use of 26, and I'm making an assumption that my modification factor will be 1.5. So it will be 1.5 times 26. We have 39. We have 39. We have 39. So let's pick a value of the LX direction. That is 3895. 3895 divided by 39. We have that to be 999. Okay, then the bar diameter, we said we are using Y12, so the half of it is 6, so plus 6, plus concrete cover, which we are using as 20 as your minimum. So this is the initial size of sectioning of the slab. So in Nigeria, for it to be approved, you have to, your minimum thickness, the minimum thickness of the slab have to be 150 for it to be approved. From what we have gotten from the initial size of section, you have 125.89. If I use 130, if I use 140, 145, actually it can actually carry what I'm about to design or what I'm designing. But in Nigeria, we said let not the thickness less than 150, even when your design shows that actually a lesser value can carry that, but the law guiding or the code guiding says the minimum is 150. So we are going to be making use of 150 for all of them. So for the worst case condition, since here is giving 150, I'm going to use 150 for all the panels. So I'm going to be using 150 for all the panels. So let's make a copy of this. Copy. Okay, I didn't copy. Copy, paste, double click, write 150, enter, 150. Then let me make a copy of this too at the center, come to the center, create this too. So it's a bit wide apart, so I've tried to make it come closer, make it go closer to that. Okay, escape, we delete this. Okay, we bring this closer to, copy. I shouldn't have used copy. Okay, but I should delete this. I'll still delete this. So we start placing it on the panels that are two-way slabs. So we're gonna make use of. We're gonna copy that. Just start placing them. The ones that are two ways. These are also two-way slab. Two-way slab. Actually, we are done placing the slabs and the nomenclatures for the slabs. Okay.